Everyone, in this video, I'm going to go over how to do solution stoichiometry. This will be a two-part series, the first part being figuring out how to write your reaction, the mass of your precipitate, and then the second video, so part two, will be how to find ion concentration. So let's look at this question. A student mixes 100 milliliters of 0.25 molar KOH, potassium hydroxide, and 100 milliliters of 0.55 molar calcium nitrate solutions. What is the mass of the precipitate formed? So first thing you always want to do is write your balanced equation. So we are mixing potassium hydroxide and calcium nitrate. I told you these are both solutions, which means that they are aqueous. So let's add that. Chemistry classes, you should know that the following ions are always aqueous. And I remember the saying NAPS. If something has one of those ions, they are always aqueous or soluble in water. And what does that stand for? N stands for nitrate. So anything that has NO3, -1. A stands for ammonium. NH4, +1. P stands for potassium, so K +1, and S stands for sodium. Spelled sodium wrong, which is Na +1. Those ions are always aqueous, or always dissolve in water, and that has a potassium, and that has a nitrate. That's why they're both aqueous. Also, I told you they were solutions, which means they're aqueous. And then let's write our products. In a double replacement reaction, the cation of one, so potassium, will bond with the anion of the other, NO3. Now you do need to think about charges. You don't just copy subscripts over. Potassium has a charge of +1. Nitrate has a charge of -1. So that is KNO3. And because we have a potassium and a nitrate ion, that is aqueous, plus the cation of the other substance and the hydroxide of the other substance will they will react, but we always have to write the cation first. So calcium comes first. Now calcium has a charge of +2. Hydroxide has a charge of -1. So I need 2 hydroxides for every 1 calcium to make those charges neutral. So it is that. And neither calcium nor hydroxide have a NAPS ion, so we can assume that's our precipitate or our solid. Step 1. Step 2, let's balance. There are 2 nitrates over here, so I'm going to put a 2 in front of the KNO3, and there are 2 hydroxides here. So I'm going to put a 2 in front of the KOH. And now it looks like everything is balanced. Step 1, done. Step 2, I've given you volume and molarity of your 2 reactants. Anytime you're given volume and molarity, solve for moles. If you don't ever know what to do, you always solve for moles. And so let's just start with the KOH. The KOH is 0.25 molar. And the formula for molarity is moles per liter. And so 100 milliliters is 0.1 liter. To get moles, you multiply both sides by 0.1. Gives us moles of KOH equals 0.025. Now let's solve for moles of calcium nitrate. The calcium nitrate was 0.55 molar. CaNO3 2 equals moles, and it had 100 milliliters, so 0.1 liter. So once again, multiply both sides by 0.01. Out there, and get that moles of calcium nitrate is 0.055. Now that we have moles of both of our reactants, let's look back at the question. What's the mass of the precipitate formed? I want to find grams of calcium hydroxide. And so to do that, Because I have moles of KOH, I can use my mole ratio to solve for moles of calcium hydroxide, and then 1 mole of calcium hydroxide is the molar mass of that. And I can repeat with the calcium nitrate. I didn't tell you which reactant was limiting, and so we have to test moles of this to see how many grams of that we can make, and moles of this to see how many grams of that we can make. And the smaller number is your limiting reactant, which is how many grams that you can make. And so let's go ahead and do that. I'll start with the potassium hydroxide, 0.025 moles of KOH. And if I go back to my balanced equation, every 2 moles of this makes 1 mole of that. You have to make sure that your units cancel out. So 2 moles of KOH will go at the bottom, and 1 mole of calcium hydroxide at the top. And then because I asked for grams, let's go ahead and solve for grams. 1 mole of CaOH2. And to find its grams, you do need to go to your periodic table. And I'm going to do that math off to the side down here. So when I go to the periodic table, calcium has a mass of 40.08. Oxygen has a mass of 16, but there are 2 oxygens, so I got to double that. And hydrogen is 1.008, but there are 2 of them, so I have to double it. And you need to add all that up. 40.08 plus mass of 74.096 grams. So that's how many grams of calcium hydroxide are in 1 mole. Then it's always good to double check that your units cancel out when you do dimensional analysis. Moles of KOH, moles of KOH, moles of calcium hydroxide, moles of calcium hydroxide, and they do cancel out. And then to do your math, you multiply across the top, you multiply across the bottom, and then you divide. And we end up with 0.025 times. That would give us 0.9292. 0.926 grams of calcium hydroxide. Now let's check our other reactant. 0.055 moles of calcium nitrate. I need to go look at my equation to see my mole ratio. This mole ratio is 1 to 1. However, even though it's 1 to 1, and that doesn't change anything mathematically, I still need to write that down. 1 mole of calcium nitrate is equal to 1 mole of calcium hydroxide. And then again, 1 mole of calcium hydroxide, 74.096 grams of calcium hydroxide. And let's type that in the calculator. That gives us 4.08 grams. And so how much can we make? You can only ever make as much as the limiting reactant allows. And so the correct answer is always your smaller amount of product, which would be that much calcium hydroxide. And then that also tells me that KOH is my limiting reactant, that calcium nitrate is my excess reactant. This video was helpful. If you watch part 2, I will go over how to find the concentration of ions.